is yet another simple observation that anyone can do at home. You have a coin and a flat table, and I'm going to demonstrate how we can make an object disappear bottom up without the need of curvature, or without the need of a physical obstruction for that matter. Now you Globers are going to sit at home and say that table is just higher than the observer height or the camera height. Now let's get that sorted quick smart. When we zoom in, we increase the focal length and increase the angular resolution, and we can resolve that coin in its entirety. As you can see, the bottom of the coin shining and when you zoom back out, the coin is unresolvable again. Nice flat table, no physical obstruction. This is all optical. There's absolutely no obstruction here. This is due to angular resolution. The angle from the observer to the coin was far too small to resolve the coin. Now when I lay it down, we can still see the coin flat on the table. No problem. And you can still see some table underneath the coin. But when you zoom out, the angular resolution is way too small to resolve that coin. Nothing to do with physical obstruction, and the table definitely isn't curving. A 100% of the light of that coin is still reaching the observer. The only thing that is creating this optical illusion of something disappearing bottom up is the angle to which you are viewing the object. As you can see, the entire coin is resolved, and when you zoom out, decreasing the focal length, it's unresolved. Now if this was a ship out in the water, all you Globers would assert that it is Earth curve creating this bottom up disappearance. But as I've just shown, angular resolution is a thing. Now what is angular resolution? Well, it all has to do with the way that we view light, whether it be from your eyeball, a camera, or a telescope. In optics, the best focused spot of light that a perfect lens with a circular aperture can make is called the airy disc. Now as you can see in this left hand side, there are 2 points of light and 2 Aries discs. They are both resolved. Now when they get closer together, this meets the Rayleigh criterion, or the diffraction limit. And so the Rayleigh criterion specifies the minimum separation between 2 light sources that may be resolved into each distinct object. And when the light sources get even closer on the right hand side, they become unresolvable. So relating this to my observation, when the coin is closer to the camera, it is fully resolved. As you start moving the coin away from the camera, it meets the Rayleigh criterion, or the diffraction limit, and this creates a smaller angle, making the coin disappear bottom up. And when you move the coin further away, it becomes fully unresolved. Now as I said, 100% of the light from that coin is still reaching the camera, it's just unresolved. But when you zoom back in, you increase the focal length and you increase the angle at what you are viewing that object. Now when you zoom in enough, it will meet the Rayleigh criterion, where you can see the 2 distinct objects again, the coin and the table. And when you get past that diffraction limit, you can fully resolve the object. Now this has all to do with the angle that you are viewing an object. Now that we know about angular resolution and the diffraction limit, let's add some distance. This pole is about 3 foot off the water, and I'm going to put my camera on top of it. This is a common observation by most people with a zoom camera of seeing a boat disappearing bottom up. But as you can see, it's definitely not going to be due to Earth curvature, as the horizon is still far in the distance. Now this is a good example of angular size. When you zoom out, it reduces the focal length, and the angular size gets so small that it reaches the diffraction limit. When you zoom back in, increasing the focal length, the angular size increases and you can resolve it again. But as you can also see, angular resolution of the image has also changed, and the horizon is still far in the background. Now comparing these two images, on the left the observer height is 1 inch, and on the right the observer height is 3 foot, and you can see clearly that the boat has started to disappear bottom up. There is no earth curve, as you can see the horizon in the background, but both boats are starting to disappear bottom up. Let's add some more distance. This is Bathurst Lighthouse from 20 kilometers away. The left image is from a 30 meter viewing height, and the right image from a 2 meter viewing height. The obstruction in the right image, the globe proponents will assert, is only from Earth curvature and nothing else. But I've shown you in this video that angular resolution can cause obstruction from bottom up without the need of any Earth curvature.
Resolution. Optical instruments are designed based on the laws of geometric optics. So, if we place a point source in front of an instrument at some distance, then the image of the point source produced by the instrument must be a geometric point. However, in reality, the light from the point undergoes diffraction and produces a bright circular patch of light surrounded by alternate dark and bright fringes. Suppose we are observing a nearby star with the help of a telescope. Here, light waves coming from these stars pass through the lens, making an angle alpha at the lens. The rays undergo diffraction and produce image on the screen. Since the distance between the stars is large, angle alpha will be large and diffraction pattern do not touch each other. Hence, the image of the stars can be seen as separate images. But if the two stars are very close to each other, the angle alpha will also be very small. The diffraction pattern of both the stars will be so close that they overlap each other. Due to this, both the stars cannot be seen as separate, and we see only one star even though there are two stars. Now, if we replace this telescope with a more powerful one, the images would appear separate. The ability to view closely spaced objects separately vary from one instrument to the other. In fact, human eye can see two point objects separately only if the angle subtended by them at the eye is greater than 1/60th of a degree or 1 minute. Based on this, resolving power of an optical instrument is defined as the ability to produce two distinctly separate images of two closely lying point objects. Rayleigh's criterion of limiting resolution. When two point objects are seen with naked eye or with the help of an optical instrument, whether the two objects are seen as two separate objects or not depends on the separation between the centers of the bright disk of the images of the objects. The two objects may be just resolved, well resolved, or unresolved. According to Rayleigh's criterion, first criteria, two-point objects are said to be just resolved if the central maxima of one object coincides with the first minima of the other object. In this condition, the distance between the central maxima of these objects y will be equal to the distance between the central maxima and its first minima x. Therefore, if y is equal to x, the points are said to be just resolved. Second criteria: if two-point objects will be well resolved if the distance between the central maxima of the two objects is greater than the distance between the central maxima of one object and its first minima. That is, if y is greater than x, the objects are said to be well resolved. Now, third criteria: the two-point objects will be unresolved if the distance between the central maxima is less than the distance between the central maxima of one object and its first minima. Therefore, if y is less than x, the objects are said to be unresolved.
This assertion of boats going over the edge of a ball earth is silly. Check out this footage from a channel called Wide Awake. This guy filmed some great sky and horizon shots showing that objects can be brought back into view, and more importantly, his shots also demonstrate diffraction and the resolution limit of these objects at those distances and at those angles. As you can see in his footage, the boats, once they are close enough to resolve, appear like little smudges, and they also appear to be floating above the horizon. The boats are not mirages floating in the air, although there is an inferior mirage that appears inverted below the actual boats in his footage. To prove this, he actually tracks them all the way in, and the closer a boat gets, the more resolved it becomes, and the more detail you can see. This is a perfect illustration of visual acuity and the angular resolution of the camera, which is obviously better than our eyes, but the principle is the same. And again, if you increase your altitude, say to the top of a hotel or in an airplane or on a mountain, you create better angles and you can of course see further, but even there you will eventually reach a resolution limit. It is unavoidable. Look at the water in his shots. Some would call the resolved water line the horizon, but you can clearly see boats fully in the water beyond the resolved water line. You can even barely make out the water being sprayed up from the motor. The surface of the water extends beyond the resolved water line, but it is too far and at too sharp of an angle for the camera or your eye to completely resolve. There's also a lot of diffraction going on due to this angle and the light or atmospheric conditions. Therefore, you get a blurred section that reflects the sky and the boat as an inferior mirage. Again, this happens beyond a point where the eye or camera can no longer clearly resolve the water due to the angle and diffraction. It is where your eye or camera can no longer distinguish points of light. The image blurs and turns into a mirror under certain conditions. Look at the shimmering and changing edges of the top of the waterline as the camera resolves it at its maximum distance. Beyond this distance, the water is at too small of an angle to resolve any detail. At this point, it does exactly what a road will do on a hot day. It reflects the light waves like a mirror because the eye or camera can more easily resolve these reflected light rays than they can the actual surface of the road or water. On the ground or on the water, you can see the inferior mirage or reflection of the boats and cars. Some people will claim that the boat itself is a superior mirage and that the actual boat is over the edge of a ball. This is silly for two reasons. Number one, a superior mirage is inverted, and number two, in this footage, he tracks these boats the entire way in, so you can verify with your own eyes how a boat will barely come into view as a small blur, And then as it gets closer and closer, the angles get larger and your eye can then resolve more and more detail. This is observable, repeatable, apparent, and can be verified by anyone.
Same reason why we see boats vanish, and it's the same reason why we see a sunset. We know that the distance to the horizon is an actual set distance. So let's say the distance to this horizon is 3.1 miles. Now let's also say the distance to this island with the city skyline is also exactly 3.1 miles away. Well, if this were the case, because we could see the face of the ground all the way to the horizon, we'll be able to see the beginning of the shoreline of this island. But if the horizon is 3.1 miles away, what if the island was 4 miles away? Well, what's going to happen is it's going to appear to be a little smaller, but it's also going to start bottoming out because you can only see the face of the ground up until your horizon. You can't see the ground past your horizon. So now let's say the island was 4.5 miles away. What would happen? Well, it would continue to look smaller, but it would also bottom out. And as the island was further away from you, it would bottom out until all you could see are the tops of the buildings, and eventually you won't be able to see anything. Now, if you were to zoom in on a horizon, you're not going to be able to see the ground any further past your horizon. All you're going to do is magnify the things that you could already see to make them appear bigger and clearer. So I'll repeat, zooming in with a camera or zooming in with binoculars or a telescope does not allow you to see further in a horizontal parallel direction with the ground. All you'll be doing is zooming in on your already existing horizon, making things bigger and making things clearer. It does not allow you to see further. Now, this kind of obstruction would happen on a ball and a flat plane, but there would be one big difference. On a ball, the further away the observer was, the more these buildings would appear to be leaning over, because your local location on Earth is always on top of the ball. You always feel upright. So if the observer was, say, 50 miles away from these buildings, the buildings are going to have a slight tilt to them. They're not going to appear vertical and parallel. That's the big difference between perspective on a ball and perspective on a plane. We never see these buildings tilting over. We never see a boat tilt over. We just see them bottom out, but they remain completely vertical.
For example, let's look at it on a smaller scale. Take a person that is walking away from you, like right here. You notice the field goal and the bleachers are all at ground level. Now watch what happens when the guy walks beyond your perspective, beyond your line of sight. Now you see, if this flat football field continued on and on, you eventually wouldn't see this guy anymore. He would disappear totally out of your line of sight. Now we all know that there's no big curve in the middle of this football field. If it was, it'd be one heck of a game, right? So now I hope you can understand that the sun does not set nor does it rise. It merely only moves out of your line of sight due to perspective.